countdown.
Congratulations! This live broadcast is specially brought to you by Academy YouTuber Malaysia, an initiative by Didik Malaysia and Kelab Guru Malaysia. Please pay attention. The live broadcast will begin shortly. The link to the certificate of attendance will be provided at the end of the session. Please make sure it is filled within the stipulated time. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. And good evening, teachers, parents, and all the wonderful students. Welcome to Pusat Tuisyen Academy YouTuber. Bermula percuma, selamanya percuma. How are you doing today? Hope all of you are ready for today's lessons. Before we proceed, let's begin our session by reciting Ummul Kitab for Muslim. For the non-Muslim, may pray according to your own religion. Al-Fatihah. A'udzubillahi minasyaitonir rajim. Alhamdulillah. Amin. Let me introduce myself. I'm Cikgu Shahnon from College Matrikulasi Pulau Pinang, the moderator of the day. We at Pusat Tuisyen Academy YouTuber will provide you with free online classes. Let's take this opportunity to do your revision. So, are you ready? Let me introduce our teacher for today's lesson. We have Teacher Tang from College Matrikulasi Selangor. We are now live on Teacher's Tang channel. Please support her channel by clicking subscribe now. The topic of today's lesson is Matter Part 1. And together with us, we also have Cikgu Mawa, who is control host, in charge ensure the smoothness of our lesson on technical support. And last but not least, Teacher Kong from College Matrikulasi Perak as an observer. Okay, before we begin, I have a few reminders to all of you. First, please pay attention to our lesson. Stop chatting and use the chat session wisely. And then regarding certificate link, the link will be given at the end of our session. Please use EDD, MOE, My Guru, and My Jawi account when you fill in your particulars. Make sure you fill in the form within the time limit, which is 30 minutes. Okay, especially for the student, I will announce the passcode of AYU credit. For your information, the passcode will be announced 3 times at the beginning, in the middle, and at the end of the broadcast. Announcement for the first passcode is letter A and number 3. I repeat, letter A and number 3. So without further ado, Teacher Tangs is welcome to present Matter Part 1.
Okay, thank you, Cikgu Shannon. So, hello everyone, I'm Teacher Tan from College Matrikulasi Selangor. So, I have around 9 years of experience teaching matriculations chemistry. So, these are my chemistry pre-U team. So, we all led by Cikgu Shannon, the moderator of today. And then together, beside me, we have Teacher Vivi Lau, Cikgu Mawa, and Teacher Kon. So beside chemistry pre-U, we also have the mathematics pre-U team, and also the biology pre-U team led by Cikgu Faiza, and also the physics pre-U team led by Cikgu Rosmaya, and also the accounts and econs pre-U team led by Madam Fizi. So now comes to the topic for today's class, matter part 1. So basically for today's class, I'm going to revise on 1.1 atoms and molecules, and also 1.2 mole concept. So in 1.1 atoms and molecules, you learn that in an atoms there are subatomic. So you learn in atoms, so divided into two parts: the nucleus, which consists of subatomic particles such as proton and neutron. And then outside the nucleus, we have electron, okay, orbiting around the nucleus. And basically, for an atom or a species, we can represent them using isotopic notation. So this is isotopic notation that we use to represent a species, be it the species is an atom or ion. And then the A here is representing the nucleon number or the mass number. And the Z here represent the proton number. Okay, so how can we get the proton number? We can get the proton number of a species by referring to the proton number of the species in a periodic table. Okay, so however, for matriculation, periodic table will not be given during the exam. So what we are referring to is the relative atomic mass table. Okay, on the relative atomic mass table, you can find the proton number, and for each of the element, they will have their own specific proton number. Okay, so proton number basically referring to how many protons actually present in the nucleus of an atom or the species. Okay, and then A here is nucleon number. How can we get a nucleon number? So basically, nucleon number, we can get it by summing the total number of protons and also the neutrons in the nucleus of an atom. By summing the total number of protons and neutrons, then we get nucleon number. And the X here basically is the symbol of that particular element. So like for example, oxygen, then the symbol will be O. And then N positive here is the charge of the species. How can we calculate the charge? So the charge can be calculated by using the formula number of protons minus the number of electrons in a species. Then we can get the charge for that particular species. So basically, again, for a species, we can represent them using isotopic notation. Okay. So in 1.1, you also learn about isotopes. So what is an isotope? What is isotopes? So basically, isotopes refer to atoms of same element with same number of proton, but then different nucleon number. Okay, like for example, uranium here, these two species, they are isotopes. How do I know that they are isotopes? Because they are atoms of same element, uranium, and they have same proton number, which is 92, but different nucleon number. So therefore, they are isotopes to one another. So however, if the questions ask you to define isotopes in terms of subatomic particles, then you should be careful on how you write your definitions of isotopes. So if we want to define an isotopes in terms of subatomic particles, how should we define isotopes? So basically, we can define isotopes as atoms of same element that have same number of protons, but different number of neutrons. Okay, again, is the uranium here. We can see that proton number 92, both 92, so means that both has same number of protons. But then as the nucleon numbers are different, so this also indicates that these two atoms have different number of neutrons in the nucleus of their atoms. So in 1.1, you also learn about mass spectrum, and then you also learn how from the mass spectrum you can determine average atomic mass of an atom, and also how to determine the relative atomic mass of an atom. But before we look at average atomic mass and relative atomic mass, if we are being given a mass spectrum like this, there are a few informations that we can extract from the mass spectrum. First, we can know that there are how many isotopes actually present for that particular element. Like for example, in this mass spectrum, we see 2 peaks. So if we see 2 peaks, means that this element basically has 2 isotopes, has 2 naturally occurring isotopes, which is chlorine 35 and also chlorine 37. So again, if we see 2 peaks, means that 2 isotopes actually present for that particular element. So this is the first information we can extract from a mass spectrum, the number of isotopes for a particular element. And then from the mass spectrum, we can also determine the relative isotopic mass of each isotopes. So if we are not being given specific isotopic mass for each of the isotopes, then we can actually deduce the relative isotopic mass from the mass spectrum. Okay, so basically we can deduce by referring to the S-axis. So S-axis is referring to the mass to charge ratio, and the number basically also telling us the relative isotopic mass for that particular isotope. Like for example, for chlorine 35. So chlorine 35, the relative isotopic mass will be 35 if provided the exact isotopic mass of that isotope is not being given, then we can use this value to do the calculation to determine the average atomic mass for this element. Okay, so for chlorine 37, the S-axis indicates that 37. So it means that if we are not being given the exact isotopic mass for chlorine 37, we can use this 37 as the isotopic mass for chlorine 37 in doing the calculation. So beside the isotopic mass for each isotopes, we can also get the abundance for each isotope from the mass spectrum. Okay, like for example, so chlorine 35, so I should change this a bit. So this is percentage abundance. For chlorine 35, the y-axis indicates that the chlorine 35, the percentage abundance is 75. Okay, while for chlorine 37, the percentage abundance is 25. Okay, so these are the information that we can also get for anisotopes, for isotopes of an element from the mass spectrum. But one thing you need to be careful is regarding on the y-axis, not all the time will be percentage abundance. So sometimes it can be relative abundance or even peak intensity, peak height, and so on. But all of that is referring to abundance of an isotope for a particular element. So basically abundance is like kekerapan. So in Form 4 or 5, you learn about statistics, you learn about kekerapan. So basically the abundance here is referring to kekerapan, okay, for a particular isotope of an element. So from the mass spectrum, we can get isotopic mass information and also the abundance. And then from those information, then we can calculate the average atomic mass of an element by using this formula. So this formula, basically you have learned in Form 4 statistics as well. So in Form 4 statistics, you learn how to calculate mean, purata, which is equal to the sum of the frequency multiplied by x over the sum of frequency. So basically, we are applying this statistic formula into the average atomic mass calculation. So I told you already, abundance here is referring to kekerapan. And the atomic mass here basically is referring to the isotopic mass. Is referring to the isotopic mass for each isotope for an element, okay, over the sum of the abundance. And then after we get average atomic mass of an element, then we can determine the relative atomic mass of an element by substituting the average atomic mass of an element into this formula. Okay, so to determine relative atomic mass, so we just need to substitute average atomic mass of an atom of an element over 1/12 the mass of one carbon-12 atom. So this is the standard set by the scientists when we want to compare the mass of an atom. Okay, so the standard is 1/12 the mass of one carbon-12 atom, and the mass of one carbon-12 atom basically is equal to 12 AMU. So yeah, so basically those are the important things that you have learned in 1.1. So now we move on to question 1. Okay, and these are the questions that usually can be asked for 1.1. So question number 1, you are being asked, what are the number of protons, neutrons, and electrons present in iron 3 ion? So how to do this question? So to do this question, first, we need to determine the number of protons. So how do we determine the number of protons? So exam, you will be given the table of relative atomic mass, and in the table, you have been given the number of protons or proton number for elements as well. So therefore, if you want to find the number of protons for an element, you just need to find it from the table. So this is the examples of the tables that will be given to you during the exam. So from this table, can you tell me what is the number of protons for iron 3 ion? So I give you 30 seconds. Can you tell me what is the number of protons for iron 3 ion? So 10 more seconds. 10, 9, 8. Oh, by the way, you can write the answer in the chat. So live chat. So you can write the answer in the live chat. Okay. So what is the number of protons of iron 3 plus ion based on this relative atomic masses table? Any answer given by the students? The number of protons for iron 3 plus ion? Yeah, Cikgu Shannon?
Not yet.
Not yet. Okay,
Okay,
so maybe I
student.
can.
You
Okay,
have a
maybe I
time.
can. Yeah,
Okay.
I can give you hints. So iron is
Okay.
here. Yeah, look at the symbol. Iron is here. So you want to find number of protons, you look at proton number. Look at proton number. So for iron, What is proton number from iron? Any answer from the students?
They're still thinking, I think.
Okay, then never mind. I will give you the answer first. So it's 26. Okay, so therefore, the number of protons for iron 3 plus ion is 26. And then how do we find the number of neutrons? So we can find the number of neutrons using the nucleon number. So just now I already told you, nucleon number basically is referring to total number of protons and neutrons present in the nucleus of an atom. So nucleon number given is 54. Proton number we already know is 26. So can you calculate what is the number of neutrons present in iron 3 plus ion? Now you can you can put the answer in the live chat so that I can see your answer. Okay, I give you 10 seconds maybe. So 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Any answer from the students?
They are too shy.
Okay, never mind. We get 28. Okay, so basically 54 minus 26, so you get 28. Okay, that is the number of neutrons present in this species. Okay, then how about the number of electrons? So just now I told you already. Okay. So just now I told you already. Okay, so how do you find the charge? So the charge is equal to number of protons minus number of electrons. So for this species, the charge is positive 3 and the number of protons is 26. So can you tell me how many electrons basically present in iron 3 plus ion in this species? So I give you 10 seconds. You can write your answer in the live chat. 10, 9.
In live chat, we have the answer from Awan Biru 28. I don't know whether there is a neutron number or proton number or electrons.
Okay. Okay.
And
Any
now
other?
we have a 23.
Oh,
I think
23. Yeah.
I think this is number of electron. I think.
Okay. Very good. Electron 23. Very good. So basically, it's 26 minus 3. Then we get 23. Very good. Very good. So this is question number 1. So we move on to look at question number 2. Question number 2. So just now we talked about isotopes, right? So still remember what are isotopes? So I told you already, isotopes referring to atoms of same element with same number of protons but different number of neutrons. So that is the definition. So for question number 2, I already defined for you what isotopes mean. So now, based on the definition, can you tell me which pair basically represent atoms of 2 isotopes of same elements? So I give you 10 seconds as well. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Any question?
No answer yet.
No answer yet?
Okay. Now we still have awan biru.
Awan Biru, what is his answer?
C.
C. Okay, so C. Okay, another key points is the questions want atoms. The questions want atoms. Okay, so maybe we can look at X first. So X is 32. So means that the nucleon number, so 32. So the nucleon number will be 72. But then electron more than proton. So remember, we want to find the charge. So 32 minus 34, we get -2. So the charge is 2 minus. So X is an ion, not atoms. Okay, not atoms. So means that it cannot be X. So Awan Biru, you want to think again, which one would be a more accurate answer? The questions want atoms. X is ion, so definitely it's not X. Maybe I give Awan Biru another 10 seconds. 10, 9,
Atom means the number of proton and number of electron are the same,
must be the same. Yeah,
right?
very good. Yes. So atom basically referring to the species with same number of protons and electrons. Okay. Yeah, any answer from the Awan Biru?
Yeah. Awan baru change the answer to B.
To B, and B cannot be the answer. Remember, same proton. So the Z definitely is not the answer because the number of protons are different. So better answer would actually be A. So shall we look at W and Y? So W proton number 32. So neutrons 40. So means that 72 the nucleon number. So proton and also electron same number. So this is an atom. How about Y? Y, number of protons 32, proton number 32, but number of neutrons 42, so means that the nucleon number 74. But number of protons equal to number of electrons, so therefore it is also an atom. Therefore, the better answer would be A, whereby both are atoms and they are isotopes because having same number of protons but different number of neutrons. Okay, so still thank you Awan Biru for trying. So now we move on to look at question number 3. So this question we need to do some calculation. The question asks us to find relative atomic mass of gallium. Okay, so I told you already just now, if we want to find relative atomic mass, first we need to find the average atomic mass first. Okay, so to find average atomic mass of gallium, we need to use the formula sum of the multiplications of abundance with isotopic mass or atomic mass over the sum of abundance. So now we can extract the information. So this mass spectrum, we have two peaks, means that gallium has two isotopes, gallium 69 and also gallium 71. Okay, so we need two informations, abundance and also isotopic mass. So isotopic mass, So just now I told you, if the question do not give you an exact mass, then you can use the mass to charge ratio given in the mass metric. But for this question, they give us isotopic mass for each of the isotope. Therefore, we need to use the exact isotopic mass given for each of the isotope. So for gallium, 69 is 68.926 AMU. And for gallium 71 is 70.925 AMU. And then for the abundance, so it is indicated by the y-axis. So for gallium 69, the percentage abundance given is 60.11%, while for gallium 71, the abundance given is 39.89%. So with this information, then we can do the calculation. So we do for gallium 69 first. We do for gallium 69 first. Shall we stop for advertisement for a while? I go and change my ink for a while because suddenly no battery.
Okay. Advertisement, please. Advertisement.
Berita baik untuk semua. Kini, Akademi YouTuber memperkenalkan sistem mata gancaran kredit AYU untuk dikumpul. Jom ikuti kelas tuition live AYU untuk mengumpul kredit AYU dan berpeluang menebus hadiah-hadiah yang menarik. Hadiah bernilai lebih RM10,000 disediakan secara percuma untuk pelajar seluruh Malaysia. Apa tunggu lagi? Tebus ganjaran hebat ini sekarang. Layari www.academyyoutuber.com untuk maklumat lanjut.
Welcome back. And before we start, we continue Teacher Tang's lesson. I will announce the next passcode. The passcode is number 2 and number 8. I repeat, number 2 and number 8. Okay, Teacher Tang, are you ready?
Yeah. So
okay.
I give students maybe 30 seconds to do this calculation because suddenly my laptop stuck.
Stuck. All right. Okay. Yeah. Right, we can see that. Okay. This is always happen to my student when we are given exact mass of isotope. They tend to use for example in this case gallium 69. They still use mass of isotope is 69, not 68.926. This is always happen. Okay, I think this is we have to stress to them that when we are given exact mass of gallium 69 in this case and gallium 71, they have to use 68.926 AMU, and for gallium 71, 70.925 AMU. And Teacher Kong, you want to add some things or whatever?
Okay, Cikgu Shanun. Okay, actually, right, while we solve this kind of problem, right, okay, we always have to remember, okay, we have to follow the rules, 3 rules. Okay, because now it's physical chemistry, we need to know, we must choose the correct formula. After formula, right, what is the next step? Substitution. But before substitution, right, we try to analyze the question, okay? Because for example, right, based on today's topic, right, is about average atomic mass, involve the sum of key. Key means the reactive atomic mass, and then key is the abundance, and then me is the relative atomic mass, right? Okay, we have to analyze the question first. After analyze, right, okay, we have to do substitution. Okay, student always tend to, okay, formula, and then they pop the figure into the formula, but they didn't look carefully or analyze the question, what figure should added to the substitution. After substitution, what is the next? Of course, you have to apply the calculation. Okay, you have to use your calculator to solve the calculation problem. Okay, calculation part, right? Okay, you have to practice, because some students, they don't know how to press the the key in the in the calculator. Okay, they tend to, okay, for example, they have to set something before the calculation. After that, you have to double check. Okay, double check the answer. You can try press for a few times. Okay, ensure that the final answer is correct. So the last step, right, make sure the final answer with correct unit. So I think teacher Tang is ready, right? Yes. How about your laptop? Okay, already?
It's still stuck. Wait.
Still
Okay,
stuck.
try and error. Okay. Let's pray for it. Okay. Okay. Okay.
Okay.
That's why student must always remember. Okay, choose the correct formula and then analyze the
Okay.
question and then substitution. Yeah. Okay.
Yeah.
Yeah. Okay. Let's
Okay.
teacher Tang continue.
Okay. Sorry about that. Okay, so just now the calculation. So we need to calculate the average atomic mass first. Of gallium. So abundance. So for gallium 69, so this is the abundance. So let me try slideshow. Okay, so this is the abundance, so 60.11%. Okay, okay. And the isotopic mass, we need to use the exact one, so which is 68.926 AMU plus the abundance of gallium 71, so 39.89, multiply with the exact the isotopic mass given for gallium 71, which is 70.925 AMU, over the sum of the abundance. So over the sum of the abundance, so 60.11 plus 39.89. Okay.
The best part about this is because this percentage, when we total
Yeah.
up, it will become 100. Okay, this is the
Yes.
best part about percentage.
Yeah, but if no percentage, then it will not be equal to
Yeah.
100. Okay, so need to be careful with what is being given to you. So 70.925. So you should get 69.72. And then for average atomic mass, because the mass is having the unit, therefore the unit will be AMU. Okay, but the question, one relative atomic mass of gallium. So therefore, you need to, after you get the average atomic mass, you need to compare it with the standard. So average atomic mass, 69.72 AMU, you already found in the average atomic mass calculations. So you compare it with the standard. So what is the standard? Basically, it is 1/12 the mass of one carbon-12 atom, which is 12 AMU. So AMU, you can cancel. 12 and 12, you can cancel, giving you 69.72. So this value basically telling you when one gallium atom, you compare it with standard, which is 1/12 the mass of one carbon-12 atom. When you compare it with standard, the mass of one gallium atom is 69.72 times heavier compared to the standard. So then now, Okay, that is the answer. We can move on to look at question number 4. So if you are being given questions like this, then how do you do the calculation? So in this question, the stated copper, the element copper have two isotopes, copper 63 and copper 65. Okay, and ask you to determine the relative abundance for each isotope. So relative abundance is not percentage abundance. So relative abundance basically is the referring to the fraction. Okay, so fraction, so therefore will be in decimal places. Okay, so fractions can be converted to decimal places. So therefore, answer usually will be in decimal places. So shall we look at this question? So how do we do this question? Like how I taught you just now. So first, write down the isotope first. And then for this question, you are not being given the exact isotopic mass for each of the isotope. Therefore, you can use the nucleon number as the isotopic mass because not being given the exact isotopic mass. Okay, and then you need to have abundance. You need to have abundance. And for this question, you do not have the abundance. They do not give you. They want you to find. So if this is the type of question, then what you need to do is you need to do assumption. So you need to assume one is having the relative abundance of X, and another one will be 1 minus X. So why is it 1 minus X? So you can think in the way that, okay, like for example, there is a class of students, so there is a class of 10 students, for example. So 7 students are female students, and I ask you, what is the fractions of female students in the class? So you will tell me it will be 7/10, right? Then how do you find the fraction for the male students in the class? So to find the fractions of the male student, then it will be 1 minus 7/10. Okay, so that is the concept here. So the X here basically is a fraction of abundance for isotope copper 63. Okay, and then why you use 1 minus X for abundance of copper 65? It is because total fraction is 1. Total fractions is 1. So copper 63 abundance is X. So therefore, the fraction abundance for copper 65 will be 1 minus X. Okay, so then we move on to look at how to do the calculation. So for this calculation, so you know that after you construct this table, you can use these informations in calculating the average atomic mass, right? Which is equal to the sum of the abundance multiplied with the isotopic mass over the sum of abundance. But in this question, you do not have the average atomic mass. Then how could you solve the abundance? Not to worry. So how can you find the informations on average atomic mass? So you can actually find from the relative atomic masses table. Okay, so you can find for copper. So where is copper? Copper is here. So this is the relative atomic mass of copper. So in the previous question, you know that average atomic mass of an element will have same numerical value with the relative atomic mass, even though they are referring to different things, but then their numerical value are the same. Therefore, you can apply that concept in this question. Therefore, for copper, if you have the relative atomic mass of copper, you can get the average atomic mass of copper, which is equal to 63.6. So remember, it will have unit, which is AMU. Average atomic mass have unit, but relative atomic mass has no unit because already been cancelled out. Okay, so then you can put that into the average atomic mass formula for you to determine what is your abundance, okay, X. So then we can substitute all the informations that we have into the formula. So for abundance for copper 63 is X. The isotopic mass is 63. For copper 65, the abundance is 1 minus X, and the isotopic mass is 65. And the total abundance will be X plus 1 minus X. And that will actually be equals to 1. Okay? And then remember, all these isotopic mass, they have unit AMU. And this one also having unit AMU. The unit can all be cancelled out. So then you can solve to find X. Okay, so 63X. And then plus 65 minus 65X. Then you can find what is your X. So your X, therefore, is equal to, okay, you should get 0.7. So means that the relative abundance of copper 63 isotope is equal to 0.7. While for copper 65, we know that the relative abundance is equal to 1 minus X, right? And our X is equal to 0.7. Therefore, the relative abundance for copper 65 is equal to 0.3. So this is the answer, the relative abundance for copper 63 and copper 65. If the questions change a bit, asking you to calculate percentage abundance, you can also use the same concept, but after you get the final answer, this is in terms of fraction. Remember, in terms of fraction. So fraction, how can you change it to percentage? So mathematics, you have learned fractions, you want to change to percentage, you need to multiply by 100. Okay, so therefore, if the question asks percentage abundance, what you need to do is, after you get the relative abundance, you can just multiply by 100 to get percentage abundance for each of the isotopes. Okay, any questions from the students?
Not yet.
Okay, no question. Okay, no question. Then I want to move on to 1.2. So 1.2 is on empirical formula and molecular formula. So you have learned to determine empirical formula. Basically, you need to construct a table. And the first row of the table, you must have the element for the compound. You must have the element of the compound. And then the second row, you need to calculate the mass for each of the element. Then in the third row, you need to determine the number of moles of each of the element. And then from there, you calculate the mole ratio in order for you to get the empirical formula. And then from the empirical formula, how do you get the molecular formula? By applying this. Okay, so you have learned this relationship in your chemistry. So in order to get the molecular formula, you can see that you need to determine what is your whole number multiple n. So how do you calculate the whole number multiple n? Is by dividing molar mass with the empirical formula mass. Okay, then you can get the whole number multiple, and then from there you can determine the molecular formula for the compound. In 1.2, for empirical and molecular formula, you learn about to use the combustion analysis to determine the empirical formula for an organic compound. So how can you determine the empirical formula for an organic compound? So you must know that organic compound usually consists of carbon and hydrogen. In combustion analysis, so basically the compound react with oxygen and will produce carbon dioxide and water. So the carbon of the compound react with oxygen will give you carbon dioxide. Therefore, by having the mass of the carbon dioxide produced, we can determine the mass of carbon that actually present in that organic compound. Okay, and then the hydrogen in the organic compound will react with oxygen to produce water. Therefore, by determining the mass of water produced, we can determine how much hydrogen that is actually present in the organic compound. So the organic compound not necessarily always having carbon and hydrogen. Sometimes we'll have the third element. So how do you determine the mass of the third element? So for the mass of the third element, basically you use the total mass of the compound. So mass of the compound. The compound consists of carbon, hydrogen, and sometimes the third element. You want to find the mass of the third element. Basically, you use the mass of a compound minus the mass of carbon and minus the mass of hydrogen. Then you get the mass of the third element. Okay, so that is the concept behind the combustion analysis. After you get the masses of each of the element, then you can construct the table and determine the empirical formula for the compound. Oh, okay, so we shall look at this question. So how do we determine the empirical formula for this compound? So first, we need to read the question and look at what are the elements actually present in the organic compound. So like in this question, given carbon, hydrogen, and there is third element, oxygen. Okay, so there is third element present, oxygen. So how do we determine the empirical formula for the compound? So I told you already, first you need to determine the mass of each of the element. To determine the mass of carbon, we can find it from the carbon dioxide, the mass of carbon dioxide. So how do you find it? Basically, you are using ratio. Okay, you are using ratio. So you know that you want to find the mass of carbon from the mass of carbon dioxide. Okay, so you want to use this ratio. So you need to know what's the relationship between carbon and carbon dioxide. You know that in one carbon dioxide, there is one carbon atom. Okay, in one carbon dioxide molecule, there's one carbon atom. So you can use that relationship to find the mass of carbon. Okay, so we can use the ratio of molar mass. So in one carbon dioxide, there is one carbon, so we can use the molar mass of carbon over molar mass of carbon dioxide to equate it with the ratio of the mass of carbon to the mass of carbon dioxide. Okay, so to find mass of carbon, we do not have the mass of carbon we want to find. The mass of carbon dioxide produced is given in the questions, 1.5 gram. We can equate this ratio with the molar mass ratio of carbon to carbon dioxide. Okay, so we know that molar mass of carbon, we can find it from the relative atomic masses table, which is 12 gram per mole, over the molar mass of carbon dioxide, which is 44 gram per mole. So the mass of carbon dioxide we can bring over, become multiply. So then it will give us the mass of carbon equal to 0.409 gram. Okay, so that is how we find the mass of carbon. We can also use the same concept to find the mass of hydrogen from water. So mass of hydrogen we can find from the mass of water. So we know that what's the relationship between water and hydrogen? So in one water molecule, there are 2 hydrogen atoms. Okay, there are 2 hydrogen atoms. So therefore, molar mass of hydrogen, we must times 2, because there are 2 hydrogen in one water molecule over molar mass of water to find the mass of hydrogen. So the mass of hydrogen we don't know, we want to find. So the mass of water produced given in the question, 0.41 gram. And molar mass of hydrogen is 1 gram per mole times 2 over molar mass of water, 18 gram per mole. Then we can get the mass of hydrogen, which is equal to 0.0456 gram. And how do we find the mass of third element? So just now I told you already, this compound consists of carbon, hydrogen, and oxygen. Carbon, you found it already. This is the mass. Hydrogen, you found already the mass. So how do we find the mass of the third element, oxygen? So we find the mass of third element, oxygen, by deducting it from the so total mass of the compound is 1 gram. So we need to deduct the mass of carbon, 0.409 gram, minus the mass of the hydrogen. Then we get the mass of the third element, 0.5454 gram. So after we get the masses of each of the element, then we can construct the table. Element, carbon, hydrogen, oxygen. So mass in gram, so 0.409 for carbon, hydrogen 0.0456, and oxygen 0.5454 gram. Okay, then we can calculate the number of moles. Mole. So how to calculate? So mass divided by the molar mass. So we should get 0.0341 moles. And for hydrogen, 0.0456 divided by 1. So we get 0.0456. While for oxygen, 0.5454 divided by 16, the molar mass. Then we should get 0.0341 mole. Okay, then we find the mole ratio. How do we find the mole ratio? Basically, all the mole we need to divide by the smallest mole. And this is the smallest mole. So 0.0341 divided by the smallest mole, we get 1. 0.0456 divided by the smallest mole, we get 1.34. Okay, so be careful with this. If you get 1.33 or 1.67, this value indicates that you cannot round out, okay, because 1.33 is equivalent to 4/3, while 1.66 is equivalent to 1/2/3. So it's equivalent to 5/3. Okay, so therefore you cannot round out. If you get like 1.34, you cannot round out. So how can you make it a whole number? Because empirical formula is the simplest whole number ratio. How do you make it a whole number? So basically by multiplying by 3, then you get the simplest whole number ratio of carbon 3, hydrogen will be 4, and oxygen 3. Okay, and this is how you get the simplest whole number ratio, and therefore the empirical formula, okay, of the compound is equal to C3H4O3. Okay, so yeah, basically that's it about the empirical formula. So I think I will stop here because since it is about the time. So next week, another teacher will continue with the 1.2, the concentrations measurements, and also 1.3. So that's it from me. Thank you. So I pass to Cikgu.
Okay, Alhamdulillah, we are done with today's lesson. We have learned a lot from Teacher Tang's about matter, especially in mass spectrum, right? Mass spectrum. Congratulations to those who are able to follow our lesson from the beginning till the end. And thank you very much, Teacher Tang, such as an interesting lesson. Okay, now it's time for me to announce the last passcode. The passcode is number 0 and number 8. I repeat, number 0 and number 8. And the presenter telegram is t.me/tangiyun. All right. Please check the chat box for the certificate link. Okay. Cikgu Mawar, you can post our certificate link, I think. And don't forget to click the bell button too, so you won't miss out any new video and live classes from Teacher Tang's. If you like today's class, then please click like and share it to your social media friends. Let's share the knowledge and receive. Let's share the knowledge you received today with them. Sharing is caring. Okay. Once again, I would like to thank to Teacher Tang for the interesting lesson, and thank you also to Cikgu Mawar and Teacher Kong for being with us today. I think that's all for now. See you in another lesson next week's. Okay, maybe we will live in 2 p.m. Okay, please do remember, stay at home and study. Goodbye, everyone. Have a nice weekend. Bye bye.
Wow, banyaknya hadiah menarik menanti anda. Wah, kini Akademi YouTuber mengambil inisiatif baru di mana memberikan hadiah-hadiah ini secara percuma. Ya, percuma kepada anda semua. Bagaimana caranya? Dengan mengikuti kelas tuition online percuma Akademi YouTuber sambil mengutip mata kredit, anda dapat menukarkannya dengan hadiah-hadiah yang menarik ini. Tunggu apa lagi? Segalanya percuma. Jangan lepaskan peluang tau. Dah dapat banyak hadiah menarik, takkan nak lepaskan peluang. Layari www.academyyoutuber.com sekarang untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi YouTuber.